Every day, thousands of airplanes carry millions of passengers across the world. And while most people are busy watching movies, sleeping, or looking out of the window, very few stop to think about one fascinating question. Why do airplanes usually fly at around 35,000 feet? Why not fly much lower? And if modern aircraft are so advanced, why not fly at 50,000 feet or even higher? As it turns out, 35,000 feet is not a random number. It is the result of decades of engineering, physics, and airline economics working together. And by the end of this video, you will understand exactly why. Before we answer the question, let's understand just how high 35,000 feet really is. To put that into perspective, Mount Everest, the tallest mountain on Earth, stands at just under 29,000 feet. That means a typical passenger aircraft is flying thousands of feet higher than the world's highest mountain. At this altitude, the sky appears darker, the air is extremely thin, and the temperature outside can drop to around minus 15 degrees Celsius. Yet inside the cabin, passengers remain comfortable, enjoying coffee, meals, and entertainment as if they were sitting in a normal room. It's quite remarkable when you think about it. But why choose this altitude in particular? Let's first look at why flying lower is not a good idea. At first glance, flying lower might seem easier. After all, there is more air available for the engines and wings. But there is a major problem: air resistance, also known as drag. The lower an aircraft flies, the denser the air becomes, and denser air creates more resistance against the airplane. Think about riding a motorcycle. At slow speeds, the wind does not bother you much, but as your speed increases, the force of the air becomes much stronger. The same principle applies to airplanes. More drag means the engines have to work harder, and when the engines work harder, they burn more fuel. For airlines, fuel is one of the largest operating expenses. Even a small increase in fuel consumption can cost millions of dollars every year. Flying lower also means dealing with more weather disturbances and turbulence. So while flying lower is possible, it is far less efficient. Now let's go in the opposite direction. If lower altitudes clear too much drag, then why not keep climbing higher and higher? After all, less air should mean less resistance, and that's true up to a certain point. The problem is that airplanes need air to fly. Wings create lift by moving through the air. Engines generate thrust by taking in air and mixing it with fuel. As altitude increases, the air becomes thinner and thinner. This creates new challenges. The wings produce less lift, the engines generate less thrust, and the aircraft gradually approaches its performance limits. Imagine trying to swim in a pool that suddenly has very little water in it. You still have space to move, but you lose the support that helps keep you afloat. Airplanes face a similar situation. At extremely high altitudes, eventually, there simply is not enough air available for efficient operation. And that's where the advantages of climbing higher begin to disappear. There is another challenge that most passengers never hear about. As airplanes climb higher, the difference between safe operating speeds becomes smaller. If the aircraft flies too slowly, it risks losing lift and entering a stall. If it flies too fast, it approaches structural and aerodynamic limits. At very high altitudes, these boundaries move closer together. Pilots sometimes refer to this narrow operating region as a small margin for error. In simple terms, the airplane has less room to adjust its speed safely. This is not ideal for routine commercial operations carrying hundreds of passengers. Airlines prefer altitudes where the aircraft remains efficient while maintaining comfortable safety margins. And that brings us to the answer. Around 35,000 feet, commercial airplanes reach a sweet spot. At this altitude, the air is thin enough to reduce drag significantly, but it is still thick enough for the wings to generate lift efficiently. The engines can operate effectively, fuel consumption remains low, and the aircraft stays comfortably within its performance envelope. It is the perfect balance, not too low, not too high, just right. This altitude also helps airplanes avoid much of the weather found at lower levels of the atmosphere. As a result, flights are often smoother and more efficient. For airlines, this means lower costs. For passengers, it means a more comfortable journey. Of course, not every aircraft follows the same rules. Some airplanes are specifically designed to fly much higher. The Concorde, for example, regularly cruised at altitudes around 60,000 feet. Certain military aircraft can fly even higher, and some business jets are capable of operating above 50,000 feet. However, these aircraft are built for different missions. Commercial airliners are designed to carry large numbers of passengers efficiently and economically. The goal is not to fly the highest. The goal is to transport people safely while using as little as possible. And for that purpose, 35,000 feet works exceptionally well. So, the next time you are sitting on a flight and looking out over the clouds, remember this. Airplanes do not fly at 35,000 feet because it's the highest altitude they can reach. They fly there because it offers the best balance of efficiency, performance, safety, and comfort. Lower means more drag, higher means thinner air, and right in the middle lies the altitude that makes modern air travel possible. 35,000 feet. Not the highest, just the smartest.